Hi friends, welcome back to my YouTube channel. So today we are going to discuss about CSMA CA, Career Sense Multiple Access Collision Avoidance. So this is from Module 2, Computer Communication EC 407 from Electronics and Communication Engineering BTECH syllabus. And let's go to the video. Before going to the video, I have already covered the previous topic like CSMA and CSMA CD in the last few videos. So you can also refer that before going to this video. So let's start the video. So career sense multiple access with collision avoidance, CSMA CA. The basic idea behind CSMA CD is that the station needs to be able to receive while transmitting to detect a collision. So in CSMA CD, in the last video we discussed, it needs to detect the collision while it is transmitting one bit from the frame. So there is no when there is no collision, the station receives one signal, its own signal. When there is a collision, the station receives two signal, its own signal and the signal transmitted by the second station. So to distinguish between these two cases, the received signal in these two cases must be significantly different. So what we need to do, like when we are detecting a collision, there must be two signal, like one that signal that is sent from the that from the sender, and another from the its own signal, and another from the signal transmitted by the second station. And these two signals needs to be distinguished, and these two signals must be differently significantly different. In other words, the signal from the second station needs to add a significant amount of energy to the one created by the first station. So that means the first station, its own signal needs to will be having another energy that is added by the other station. So, in a wired network, the received signal has almost the same energy as the sent signal because either the length of the cable is short or there are repeaters that amplify the energy between the sender and the receiver. This means that in a collision, the detected energy almost doubles. So, in a collision, when we are detecting that collision, the energy is almost doubles. However, in a wireless network, much of the energy is lost in transmission. The received signal has a very little energy. Therefore, a collision may add only 5 to 10% additional energy. This is not useful for effective collision detection. We need to avoid this collision on wireless networks because they cannot be detected. So why we are using CSMA-CA? In wireless network, we cannot actually detect these signals. So we need to avoid the collision in wireless network. So that's why we are using CSMA-CA. So carrier sense multiple access with collision avoidance was invented for this network. Collisions are avoided through the use of CSMA-CA's three strategies: the interframe space and the contention window and acknowledgements, as shown in figure. So the figure shows the three strategies: interframe space, contention window, and acknowledgement. So when the channel is busy, continuously sends and found its ideal, then interframe space is there, and the convention window is like size, binary, exponential, and it will send frame and timeout. So let's go to the first strategy, interframe space, IFS. First, collisions are avoided by deferring transmission even if the channel is found ideal. When an ideal channel is found, the station does not send immediately. So when we are finding that the channel is ideal, we are not immediately sending any data through that. It wait for a period of time called interframe space. So it will wait for some time, that is called IFS. Even though the channel may appear ideal, when it is sensed, the distant station may have already started transmitting. So the distance between the signal that has not yet reached the station, the distant station signal has not yet reached the station. So there is a possibility, like when we are waiting for the when the channel is ideal and we are waiting, when it is ideal, when it is sensed, a distant station may have already started transmitting, and the distant station signal has not yet reached the station. The IFS time allows the friend of the transmitted signal by the distance station to reach the station. If after the IFS time the channel is still idle, the station can send. But it still needs to wait a time equal to the connection time. So the connection time is the second strategy that we will discuss next. And the IFS variable can also be used to prioritize stations for or frame types. For example, a station that is assigned a shorter IFS has higher priority. So IFS time allows the friend of the transmitted signal by the distant station to reach this station. And if after the IFS time is still and after the IFS time the channel is still idle, the station can send. And but it still needs to be wait a time equal to connection time. So next is connection window. So the second in figure you can see it is the second part binary exponential. There is a connection window. So the connection window is the amount of time divided into slot. It's a time that is divided into slot. A station that is ready to send chooses a random number of slots as its wait time. So the number of slots in a window changes according to the binary exponential back of energy. The number of slots in the window changes according to the binary exponential back of strategy. This means that it is set to one slot the first time and then doubles each time the station cannot detect ideal channel after the IFS time. So this means that it is set to one slot the first time and then doubles each time the station cannot detect the ideal channel after the IFS time. So this is very similar to the P persistent method except that a random outcome defines the number of slots taken by the waiting station. One interesting point about the connection window is that the station needs to sense the channel after each time slot. So, in connection window, the station needs to sense the channel after each time slot. So, however, if the station finds the channel is busy, it does not restart the process. It just stops the timer and restart it when the channel is sensed as ideal. This gives priority to the station with the longest waiting time. So in IFS, the station that is assigned a shorter IFS has the higher priority. In connection window, they gives priority to the station with the longest waiting time. So in CSMA CA, if the station finds the channel is busy, it does not restart the timer of the connection window. It stop the timer and restart it when the channel becomes ideal. So acknowledgement is a third strategy. With all these precautions, there still may be a collision resulting in destroyed data. In addition, the data may be corrected during the transmission. The positive acknowledgement and the timeout timer can help guarantee that the received signal receiver has received the frame. So that is all about the three strategies in CSMA CA. And next is the CSMA CA algorithm we are going to discuss. So we can go to the figure. So there is a start and K, we are setting K equal to 0. And then it is going to the conditions like ideal channel. If it is yes, it will go down, wait for the IFS time. If it is no, it will repeat the process from, it will start from K equal to 0 and then again it will goes to the um, this condition, and once it is yes it will goes to wait for IFS time interframe space and still ideal yes, then it will go down, choose a random number between r between 0 to 2k raised to 2 raised to k minus 1. If it is no, it will again go to k equal to 0 and then it will again check ideal channel or not and wait for IFS still ideal. If it is yes, then choose a random number between 0 to 2 raised to k minus 1 and then wait r slots and send frame wait timeout, then acknowledgement received yes, then it is a success, and if it is not, then k equal to k plus 1, k will be changed to k plus 1 and then it will goes to a decision box that is k greater than 15. If yes, then it will abort the process. If it is no, then it will again check for the channel is ideal or not, and if it is yes, then it will it will loop the same process, and if it is not, it will go up and again check the channel is idle or not. So this is the overall process of CSMA CA. It is very simple. If you have asked in your question paper, if you are asked to answer this question about CSMA CA, you can directly mention this figure and explain the process in line by line. And each process you can, it is very simple as you can see in the figure. So that is all about the algorithm of CSMA CA. So the procedure you can tell, note that the channel needs to be sensed before and after the IFS, and the channel also needs to be sensed during the condension time. For each time slot, the condension window, the channel is sensed. If it is found ideal, the timer continues. If the channel is found busy, the timer is stopped and continues after the timer becomes ideal again. So this points you can include in the answer sheet as well. This is also important. CSMA CA and network, wireless network. CSMA CA was mostly intended for use in wireless network. The procedure described above, however, is not sophisticated enough to handle the particular issues related to the wireless network, such as hidden in the terminals or exposed terminals, etc. So these are all about CSMA CA. So we have three strategies: interframe space, connection window, and acknowledgement. You can also refer this figure and draw this figure for more clarity, and also explain what is connection window and what is IFS, and then acknowledgement. So these points you can also mention in the, I mean, you can get from the flow diagram itself. So try to learn the flow diagram, that is very important, and then you can explain all these points in a paragraph like one by one. So that is all about today's section. I think we can wrap this section by now. So thank you for watching my video. If you like this video, please subscribe my channel, like, share and comment. See you in the next video.